Hey everyone, welcome to the first part of neural networks, where we'll discuss the origins of them and how they were created. So, neural networks are based on biological neurons found in our bodies. So, there are three main parts: the dendrites, the nucleus, and axons. The dendrites are the input, whatever information you take in around you, like the computer you're staring at right now. The nucleus is the processing of that information. How you know your computer is, well, your computer. And axons are the output, where you finally know that you're actually looking at your computer. So, to summarize, dendrites basically accept input signals, does something in the nucleus to process that information, and outputs that in the axon. So, how did we get neural networks in the first place? In 1958, the perceptron model was created, again, based on a biological neuron. It had inputs, outputs, and a nucleus. The nucleus is a function, f of x, that does something to the inputs and produces the output. For example, let's say f of x has two inputs, x1 and x2, and it's a simple sum function. Then f of x is just y equals x1 plus x2. But the interesting thing about the perceptron model is that it can learn to become more and more accurate. We can add weights to adjust the inputs, which can be positive or negative. We multiply these weights with the input. Now, y equals x1 times weight 1 plus x2 times weight 2. But what if x is 0? Then the weights have no effect, because then it would just all equal 0. That's where biases come in. Biases are added to the input so that even when x is 0, the inputs can still be adjusted. So, adding both the weights and the biases, our equation becomes y equals x1 times weight 1 plus b plus x2 times weight 2 plus b. So far, we've only been looking at a simple sum function. Let's generalize this perceptron model for any function. So we can generalize this perceptron model for n number of inputs. This equation might look complex, but all it's saying is that y equals x sub I times w sub I plus b sub I, where the I increments by 1 for all of the n inputs we have. This is the mathematical generalization. Later, we can see how to expand this formula to have x be a tensor, which is an n-dimensional matrix. And you'll learn about tensors more in the next videos, where we actually see how a neural network functions with multiple different inputs. So that's it for this video, but I'll see you guys in the next one, where we'll discuss what a neural network actually is. See you guys there.